Hello children all over the world. We are going to discuss today about a topic which is very important, especially if we talk about the higher classes, class 11 and class 12, be it any board, say the ISC board or the CBSE board or the IGCSE board or say the IB board or different state boards or different foreign boards. I'm sure this topic is one which is definitely covered. So here, in application of derivatives, that means after we differentiate a function, we get to an expression, right? That is known as the derivative. For that matter, if say we talk about a function and let's say the function f of x is say some x raised to the power 2 minus 4x plus 7. For that matter, it can be any function. It can even be a trigonometric or probably an exponential function. Now if you differentiate this, I'm sure you people know this, that f dash x is going to come equal to 2x minus 4. So here we are not going to discuss about the nitty-gritty of how we came to this. I expect you people to have learned differentiation. If not, you can look up an earlier lecture. So if this is the expression which has come after differentiation, this expression, children, is known as the derivative. Okay, so this is the derivative, and when we have found out the derivative, that actually has a lot of applications, right? One of the applications that we normally study is tangents and normals, then we have rate as a measure, then we have maxima minima, then we have approximation, then we also talk about monotonous or increasing and decreasing functions, right? These are the normal 5 application of derivatives. Obviously there are more if you talk about statistics, if you talk about economics, or if you talk about other subjects as well. There are some of the other applications of derivatives. Okay, now that you have understood that we have these 5 different applications that we'll be studying to cover up the syllabus of class 11 and 12, right? Let us quickly discuss the first one, which was tangents and normals. Okay, so let us now, children, consider that we actually have a function like the one that we've discussed here, right? And as you look at it, you can directly say that this is a vertically upward parabola, right? For that matter, let's consider that this is any function, and now at this time I'll be making just any graph. Okay, so first let us make the basics. That is, we have our x-axis and then we'll be having our y-axis, children. Okay, let us say now that we have the y-axis, and the y-axis say looks something like this, right? Okay, let's hope that this is perpendicular. So now that we have this straight line which represents the y-axis and the earlier one which represented the x-axis, right? Now we can easily say that we can now have the graph of the function. And let's say if we talk about the graph of the function, it say comes out to be say something like this. I'm not going to go about the nitty-gritty of all of this. It might be say plotted at a different point, but let's say we talk about a vertically upward graph, right? And let's say this is that point. Now if you are interested in finding out the tangent to the graph at a specific point, for that matter here we'll be drawing a straight line, and that straight line, let's say, touches the graph at a point like this. So if you talk about this point, which is say the point at which the tangent or a straight line which touches the graph at this point has been drawn, right, you can say that this point can be named to be say some x1 comma y1, right? And if you talk about this straight line, children, is the tangent. Now what we are interested in is interested in finding out the slope of the tangent. Now children, the slope of the tangent is represented by small m, and in the suffix we'll be writing small t. So that is the slope of the tangent. So if you find out the slope of the straight line, then you'll be able to get to the slope of the tangent, which is also known as the slope of this graph at this point. We can, for that matter, name this point to be say some point P. right? And by finding out the slope of the tangent, we'll be able to get to the slope of the graph at this point. Now there is another characteristic straight line which passes through this point, and that is known as the normal. So we'll now be drawing another straight line, and that straight line is going to pass through what? It will be passing through this point x1 comma y1, and it is going to be perpendicular to this straight line which is already existing, right? Let's now make this to be of a different color, then you'll be able to understand this much more. So if you talk about this, let's say we make it of a different color, then you'll understand much more. Now children, we get to see that there is actually an angle of 90 degree which is between both of these, right? So if you talk about this angle that we have at this space, right, that is 90 degree. So if we talk about this second line, the second line is what? The second line is actually the normal. Okay, and the normal obviously will be having a slope which can be written by capital M and in the suffix n. And since both of these are perpendicular to each other, so obviously you can write a relation that we have the slope of the tangent multiplied with the slope of the normal, right, which becomes equal to, everybody can say this, that's going to become equal to -1, right? So the product of the slope of the tangent and the normal is equal to -1. So if you get to the slope of the tangent, very easily you can find out the slope of the normal. And since you have this point at which the slopes of the tangent and the normal have been found out, so if you want to find out the equation of the tangent or that of the normal, you will directly be using an equation which you studied in class 10, that is the 1-point form, that is y minus y1 is equal to m times of x minus x1. Now children, when you talk about the tangent, then here you'll be replacing this m by mt. However, if you are talking about the slope of the normal, then you'll be replacing this by small n, which actually is the slope of the normal. Thus, in both of these cases, you'll easily be able to get the slope of the tangent or that of the normal, right? So one change you got to make, and that is this, that this point this variable which is m can either be written to be capital small m n, or it can be kept to be small m t, right? So if you're going to find out the straight line which represents the tangent or the normal, you will keep their relative values for tangent mt and for normal mn, and thus you'll be able to get this straight lines equation. So all of this that we've studied, I'll just quickly revise with you people so that there is no doubt whatsoever, because as you have seen twice, you've been able to peep that there is a sum which is waiting for your dispersal, right? So you are the person who's going to try it out, and when you can't and you say, you drop your weapons and say that, okay, I'm helpless, I'm not able to do it, then I'm going to help it for you people, and then you will have to do it once more so that you can understand all of this concept, and when a sum like this comes, you're able to handle it. Okay, so children, we are talking about application of derivatives, remember, in which we are talking about any function which can be graphed in 2 dimensions. So in the xy plane, we have this graph which has been plotted, and now if you find out the derivative of this function, it actually represents the differentiation process which has been done on the equation of this graph as y is equal to f of x. So that's why when we differentiate this whole equation, on the left hand side you'll have f dash x, which is dy upon dx, and then this expression will represent the derivative of the equation of the curve. Now since this gives you a upward parabola, so we've drawn it something like this, and let's say p be a point x1 comma y1 at which you want to find out the slope of the graph. So what we do is, at this point p, we will be drawing a tangent, right? And this tangent, which is actually passing the point x1 comma y1 and is also just touching the graph at this point p, if you find out the slope of the straight line, that becomes the slope of this curve at this point p, right? Now in order to find out the slope of this tangent, either we can find out this angle, right, which normally has to be done geometrically, and that is a different entity. Now if we want a value hands-on, what we do is we just find out the derivative of the function, and whatever is in the derivative, if it's an explicit function, it will be all in terms of x, and then in place of x you'll be substituting x to be x1. However, if it's an implicit function, you'll be substituting the value of x quotient, that is x1, and the y quotient, that is y1, and thus you will come to the derivative at this point x1 comma y1, which will actually represent the slope of the tangent at this point. Right now, children, you have the slope of the tangent, and since you know that, to find out the equation of the straight line, which is the tangent, you can use the 1-point form, that is y minus y1 is equal to mt times of x minus x1. You will get the equation of the tangent. That's it. Now there's another straight line which is characteristic and passes through this point x1 comma y1, but is perpendicular to the tangent. So the slope of the tangent multiplied with the slope of the normal will give you -1, as you said in class 10, right? And thus you would have found out the slope of the normal now, and using this equation, which is again the 1-point form, you will be able to find out the equation of the normal as well. So using these concepts, I expect you people to quickly try out this question. I will be giving you some time for trial, and after which I'll be discussing the sum with you people. Okay, now if you're not able to do this in 10 seconds, which normally I will give you, I can't give you too much time, right? You are expected to pause this. Now you expect to write all of this data that I've told you, and then you are expected to learn all that up and write it once, so that all of that seeps well and gets assimilated with you people for a long duration of time. After that, you know the concept, you have the sum before you, give it a good try, right? Don't think that you can just look up the solution. This is no cinema. I'm helping you out with these sums, and you require to help yourself out by doing the sums once first on your own, and then when you can't do, then you require to look up what the solution is and do it all on your own once, right? So at this time, giving you people some 10 seconds for trial. I hope you people are seated at a place so that there is no disturbance, no cousins, friends, girlfriends, boyfriends, parents around you, and there is no electronic gadget which can easily deceive, disturb, and disperse your attention. So make sure that with all of these rules, you now have tried out the sum well, and I expect that as you've tried out, now it is my turn to be able to explain the sum with you people. So children, let's read what the question is. The question has this, that find the equation of the tangent to the curve 3x square minus y square is equal to 2. Now children, if we talk about this equation, you find that there is x, there is y, and the coefficient of x square and y square is such that one is positive and the other is negative, and then that's equal to 2. So obviously this must be representing a hyperbola. We're obviously not going to trace it like that, but even then we should just have an idea. If we have an equation, then what does it represent? Then the next thing is that as with x square we have a positive sign, so as such what you can do is you can consider that this is a horizontal hyperbola. Okay, after we have that, next what we do is we now talk about tracing this out just like that, and then we have a point, right, at which we're going to talk about the tangent, right, and its equation is to be found out, right, and this tangent is such that it is normal to the line x plus 3y is equal to 2, right? So let's first graph it out, then I'm sure you'll be able to understand much more. So now drawing the graph for you people, let's say we talk about this to be the y-axis, and let's say now we have the x-axis to be, say, something like this, and then after that we now have the x-axis and the y-axis. Now I'll be telling you people that let's draw the graph. For that matter, if say we talk about the graph to be, say, something like this, right, we are not going to further proceed ahead. We will consider a point on it on which we have to draw a tangent. So let's say now that the tangent that we're talking about is actually this point at which the straight line is touching the graph, right? And after that, then what you expected to do is you expected to find out the slope of the tangent at this point, right? So this is the point, say, which say is some x1 comma y1, right? We've got to find out the equation of the tangent at this point. Now there is another straight line, right, to which this tangent is normal, right? So we can draw another straight line. Let's say we now talk about drawing a straight line, say something like this, and this straight line, children, is such that it is perpendicular to our required line, right? So as there is an angle of 90 degree, now next I'll be making an angle of 90 degree. So if you talk about this straight line, children, this straight line is x plus 3y is equal to 2, and let us represent this by, say, some line L1, right? And now if you talk about the slope of the straight line, as it is perpendicular to the tangent to the curve, right? So when we find out the slope of the straight line, then minus times its inverse will be the slope of another straight line which is actually parallel to the tangent, right? And thus, as m1 is equal to m2 for two straight lines which are perpendicular, which are parallel, as such that will become the slope of the tangent. Okay, so next now, children, what we will do is we will now first talk about the straight line, right? So we now start solving our sum. We talk about this line L1 that we've been given, and for this line L1, children, what we have is we now have here that x plus 3y, right, is equal to 2, right? As such, if we try making y the subject of the equation, we will have 3 times of y, which will become equal to minus x and plus 2, right? And further, children, in the next step what we can do is we can write this to be y to be equal to minus 1 upon 3 times of x plus 2 upon 3, right? Now, children, if we compare this with y is equal to mx plus c, that we can write here, comparing with y is equal to mx plus c, we will now get the slope of the tangent. And children, the slope of this straight line L1, which is actually perpendicular to the required tangent, right? So we can write that first let's write the value, right, and then we'll talk about the rest. So we can say that ml1 is equal to how much? It's equal to minus 1 upon 3, right? And next, children, you will write this, that as both these straight lines are perpendicular, that is, since L1 is perpendicular, right, to the tangent, so as such, if we now talk about the product of the slopes of this line L1, right, and the slope of the tangent, so that will become equal to minus 1. As such, then you can find out the slope of the tangent very easily. So the slope of the tangent will become equal to minus 1 divided by slope of the line L1. Now, since the slope of the line L1 is how much? It is minus 1 upon 3, so both the minus signs will get cancelled. As such, 3 will reciprocate to the numerator, and we will have 3, which will become the slope of the tangent. Now, children, that we have the slope of the tangent, right, we know that when at this point x1 comma y1 there was a tangent which was drawn, then the slope of the tangent has come to be equal to 3, right? Now, next what we do is, as we have found out what the slope of the tangent is, now we've got to find out the equation of this straight line, right? Now you can get the slope of the tangent in another way, that is by differentiating the equation of the curve and keeping the value of x1 and y1. So we will now say, finding slope of tangent by differentiation. Now remember children, if you just look at what I'm doing and don't concentrate or focus, then you will not be able to understand everything. You have to generate this feeling from yourself that I have to understand this just now, right? And you've got to accord it maximum amount of importance, only then you'll be able to understand. Okay, now we'll be going ahead to find out the slope of the tangent by differentiating the equation of the curve. Now equation of the curve is 3xy minus y square is equal to 2. 3x square minus y square is equal to 2, and if we are to differentiate, we are to find out d upon dx of both the sides, right? So here also we'll do the d by dx. So let's first write d by dx, and then we can put up an equal to sign in between, right? And for the children here, for the first term you will get 6x, and then you will get minus 2y times of dy upon dx, because y in itself is also a function in x, and that children will become equal to 0 because the derivative of a constant is 0, right? So here children, we have just used a simple formula. I'll tell it to you people. If we talk about d upon dx of say some x raised to the power n children, then that becomes n times of x raised to the power n minus 1, right? And except that, we also have used another rule, that is, if we talk about d upon dx of any constant a, it can be 4, 3, minus 143, so that is 0, right? So this is the second rule that we've used. So further here, our task is now to make dy upon dx the subject of the equation. So we'll have 2y times of dy upon dx taken to the other side of the equation, and thus making it positive. And on the left hand side, we'll now have 6x, which obviously can also be written on the right hand side. Now we find that 2 cancels 6 3 times. As such, we can now say that we have dy upon dx, which actually is the slope of the straight line, to be equal to how much? 3x upon y, right? And now we can say that if we talk about the slope of the tangent, then the slope of the tangent can be written by writing in dy upon dx in place of x, x1, and in place of y, y1, because it is the slope at the point x1 comma y1, and thus here in this case this is going to become equal to 3x1 upon y1. Now children, remember that this we've already found out to be how much? 3, right? Thus the slope of the tangent is also equal to 3, and here we can say by which equation we can mark this to be say some equation number 1, right? So we can say that we are doing this by what? By the knowledge that we have of equation number 1, right? Now children, here you have 3x1, which actually is equal to what? It is equal to 3. So as such, 3 can be cancelled off from both the sides, and thus you can now write x1 to be equal to y1, which has come into being, right? So if x1 is equal to y1, one of the coordinates can be say 3 comma 3, another coordinate can be 7 comma 7, and so on, right? So this actually is that equation which helps you in finding out the tangent, but it actually has given you a relation for the different coordinates which are possible in this curve, right? So here now next children, what we do is we will again talk about the equation of the curve, that is 3x square minus y square is equal to 2, and we'll find out the coordinates at which this is happening. Now you will say here equation of curve satisfies these points, right? So the point that you can be talking about here can be the point which is what? It is x1 comma x1, because x1 is the same as y1, right? So if you talk about the equation, we have the equation to be, if I'm right, 3x square minus y square, is it 3x square minus y square is equal to 2, right? So 3x square minus y square is equal to, and now when you substitute, right, you will get 3x1 square minus you have x1 square, which becomes equal to 2, right? This is on substitution. So obviously now you will have 2x1 square, which will become equal to, and now here you get to see that 2 and 2 will get cancelled. As such, you will get x1 square to be equal to 1, right? Thus x1 square is equal to 1, and thus you can say that x1 square minus 1 square will become equal to 0, or in other words, you will have x1 minus 1 times of x1 plus 1, which will become equal to 0. Why so? Because you know this, that if you have a square minus b square, children, then that is equal to a minus b times of a plus b, right? And that is the reason why what you do is you can now write here the value of x1 that you found out. The first value of x1 is 1, and at the other time it is minus 1 by applying the zero product rule. And this tells you, since x1 is equal to y1, so y1 will also become equal to 1 or minus 1. So next, now we can talk about the points. So the points will thus be 1 comma 1, or it will be minus 1 comma minus 1, right? Now children, is the task of finding out the equation. Therefore equation of tangent, this, children, can be given by the equation that you learned of 1 point form in an earlier class, that is y minus y1 is equal to m times of x minus x1, right? And here, children, you will say that you already know the slope of the tangent, that is mt, and if I remember correctly, it's 3, right? So mt is 3, children, and that is what you will keep here in place of m. And you will say this, that since mt is equal to 3, therefore you will have the first line to be y minus 1 is equal to this 3 times of x minus 1, right? Which obviously solves to y minus 1 to be equal to 3x minus 3, and thus you will have 3x minus y, right? And then further you will have minus 3 plus 1, which will become minus 2, right? And that becomes equal to 0. So children, this is the first equation that you have of the tangent. And then in the second case, when it is the point minus 1 comma minus 1, this obviously was for the point which is 1 comma 1, right? And next, children, we talk about the second point, which is the point minus 1 comma minus 1. And then, children, this is going to become what? This will become y minus y1, that is minus 1, is equal to m, which is 3 times of x minus x1, that is minus 1, right? So further here, children, next we can say that we have y plus 1 to be equal to 3 times of x plus 1, right? So here thus we have y, right, which obviously can be taken to the other side, so we'll rather take it to the other side. We have 3x plus 3, right, minus 1, right, and minus y, which becomes equal to 0. So as such, we have 3x, right, and then we have minus y plus 2 is equal to 0. So children, this is the second equation that we have. So one of the equations is this, right, and the other equation that you have is this, right? So these, children, are the two equations that we have. One is this, and the second is this. Well, just remove the color. Okay, this now has to be placed here. Okay, So these children are the two answers. We'll mark this also to be equation number 2, and I'll re-explain all of this to you people. So children, in the question, what have we been given? We've been given that there is a curve whose equation has been given to you, right? And the curve has been given to you to be 3x square minus y square is equal to 2, right? And if you watch it carefully, this is actually the equation of a hyperbola, right? So it is going to be a curve like this on either side of the equation, right? And here further, we've been given that there is a straight line to which the tangent drawn at a point x1 comma y1 is going to be perpendicular to another given line, right? So find the equation of the tangents to the curve which are normal to this, right? So this is one of the tangents and it is normal to the straight line, and the straight line's equation has been given, right? So easily we can write it in the form of y is equal to mx plus c and find out the slope. The slope comes out to be minus 1 upon 3, right? And this obviously is going to be multiplied with the slope of the tangent to give you minus 1, as both of these straight lines are perpendicular to each other. So here we will say that since the line L1 and the perpendicular and the tangent are perpendicular, right? Rather here we'll just change it a little. That is, if we talk about this if we talk about this the line L1, right, and if you talk about the tangent, right, both of these are what? Both of these are perpendicular, right? And since both of these are perpendicular, so obviously the slope of the line L1 into the slope of the tangent, right, as both of these are perpendicular to each other, will become equal to minus 1, right? We've already found out the slope of the straight line, which is minus 1 upon 3. So as such, the slope of the tangent can be found out to be minus 1 upon slope of this line L1, right? So minus minus gets cancelled. You have 1 upon 3. Thus the slope of the tangent becomes equal to 3. Next, children, to find out the slope of the tangent by differentiation, that is also what we can do when we differentiate the equation of the curve. So we have this to be the equation of the curve, which next now we are going to differentiate, and on the left hand side you will get here the derivative of x square, which will become 2x multiplied by 3, so that will become 6x minus 2y, which will become equal to 0 because the derivative of a constant is 0, and the derivative of some x raised to the power n is n times of x raised to the power n minus 1. Now further here, next what we do is we cancel off this 2 with 6 3 times. As such, we get the value of dy upon dx to be 3x upon y. But actually, as this gives us the slope of the tangent where the point is some x1 comma y1, so when we substitute this x1 and y1, we will get 3x1 upon y1. Now this is the slope of the tangent, and the slope of the tangent has already been found out to be 3, so we keep that value. 3 gets cancelled, and as such we are left out with x1 to be equal to y1, which in times to come is going to help us to find out the point, which will actually become x1 comma x1, as now in place of y1 we can replace it to be x1. Now we can substitute it in the equation of the curve and get the value of x1. So we have 3x1 square minus x1 square is equal to 2 to get cancelled from both the sides. We get the value of x1 by applying a plus b times a minus b, right, to be plus 1 and minus 1. And similarly, the value of y1, as it is equal to x1, will become 1 comma minus 1, right? So the points are either 1 and 1, or they are minus 1 and minus 1. Now to find out the equation of the tangent, you have to use the 1-point form, which is y minus y1 is equal to m times of x minus x1. For the first case, when the slope is 3 and the point is 1 comma 1, we'll have y minus 1 is equal to 3 times of x minus 1. On simplifying, this becomes 3x minus y minus 2 is equal to 0, which is one of the equations of the tangents. And at the other time, when we keep the value of the point minus 1 comma minus 1, slope remaining to be 3, which is the slope of the tangent, we get the equation to be 3x minus y plus 2 is equal to 0, right? So children, these are the two equations which represent the tangents of the graph at the point 1 comma 1 or 1 comma minus 1, which are going to be perpendicular to the given straight line. So is all of this clear? I'm sure all of this is clear. That's good. You'll have sums of this type, or probably a little different, but now as you know the concept of tangents and normals, I'm sure you're going to do that with ease. So do practice this. This is what I expect out of you, right? So make sure now that you pause this lecture and you write everything, all that you've learned, the notes, and after that you also do the sum all on your own. If you require to look it up once more, make sure that you do it once more, and then make sure that you write all of that, right, such that it is perfect. Then take a click of it, right, a pic of it, okay, and crop it and send it to my email ID, the mathematics helpline @gmail.com, and then I'll get to see that you are actually working hard, right? And in times to come, as I get your email ID, I will also send you useful stuff which you require. You can even ask me questions in this email ID, or you can also tell me about topics in which you require more understanding. I will provide you with more help the moment you tell me, sir, I require this, right? But all of that is going to happen by email. That's why I'm asking you to send me this work all done all by yourself in my email ID, the mathematics helpline @gmail.com, and I'll get back to you and ensure that your maths is perfected. Bye children, have a nice time, enjoy your lives. Bye.